equation. We know we are expecting to have some variables and solutions and so on. Now, what is differential equation, which has also the word, right, differentiation in the title? So I'm just going to start and say that any equation you dealt with so far had x equals a number, or xy equals an ordered pair, or something along those lines. So if you had your x plus 3 equals to 5, solution was x equals to 2, and you can plug that 2 back for x and check and know that that's a good solution. Maybe you had e to the x is equal to 8, and then you solve that one, you get x equal ln 8, right? So you dealt with many equations in the past: trigonometric, logarithmic, exponential, polynomial, all different types. And now it's time to see what the differential equation would be. So differential equation is the equation which contains a function and its derivatives. We usually write it this way. So some kind of differential equation would be this function which contains all of these other features like variable t, which is independent variable. We usually use t because in life things evolve with time. They evolve with time, so we use t. So we have now the definition for differential equations. Take a look at some examples. So you could have a differential equation, looks like this: y double prime plus y plus 6t is equal to 0, let's say. So you see the second derivative, you see the first derivative, you see the independent variable. So something like this is known as the second order differential equation because you have a second derivative. Also, if you write, maybe much easier, y prime is equal to, I don't know, t plus 3. This would be the first order. First order linear and so on. So there are many of these examples. Still one from the book. Y prime plus 4y is equal to cosine x. There's a lot to be learned. Well, we use t, so let's use t. There's a lot to be learned in terms of classifying these as linear, nonlinear, classifying them as the first, second, third order, and so on. There are different classifications, and you will go into those details when you take differential equations class. This particular section is introducing the idea of differential equation, and it's also introducing the idea of having a function as the answer, because you can see that we have the unknown function y, or f of x, which is showing up everywhere, and we are supposed to figure out what that function is by using whatever methods are available in that course. So what am I going to do here? Well, let's talk about first y double prime plus 5y prime plus 6y is equal to 0. Earlier I used 16, now I'm using 6y. Now we're not going to learn how to solve this equation. We are just knowing now that this is differential equation because it has two derivatives and then a function. Now I'm going to write a solution for this, which would be c1e to the, let me just see, the factors. I'm factoring quadratic, basic quadratic, so that's going to be plus 2 and plus 3. So plus 2 plus 3, so minus 2t plus c2e minus 3t. There we go. So this would be known as the solution to the differential equation. That's known as the solution to the differential equation. It's known as general solution. There is a particular one when you figure out what C1 and C2 are, and so on. So now, observe that the solution is a function. So these equations are higher order creatures than equations that you are used to so far. Equations that you know so far, which you use to find limits and all other things, they all have as answer a number. Differential equations have functions as answers. So this particular function is the answer. And you can check by figuring out the first and the second derivative of this, and you plug all of them in the original equation and make sure that everything cancels to be equal to 0. Does this make any sense? Awesome. So we are differentiating this now, and we're going to plug everything in the original equation to check. So to check the solution, differentiate and plug in to the original problem. So y prime of t is going to be negative 2 c1e minus 2t minus 3c2e minus 3t. We also need a second derivative, which will be 4c1 e minus 2t plus 9c2 e minus 3t. So now we have y2, we have y prime, right? Y double prime, y prime, and a regular y, and we just plug them in where they belong. Literally what I'm doing is I'm plugging that, you remember x plus 3 equals 5? And we got 2. 2 plus 3 is 5 to check. That's exactly what I'm doing here. This y prime, which is the long expression, will replace the y prime. The y double prime. Y single prime will replace this one, then you distribute 5, and then y will replace there, distribute 6. And when you add them all up, they will all cancel, and we'll have the check. So let's do it. Check procedure. 4c1 e to the minus 2t plus 9c2 e minus 3t plus 5 times the first derivative, which is negative 2 e minus 2t minus 3c2 e minus 3t. And then we have plus 6 times the original y, which is c1 e minus 2t plus c2 e minus 3t. And that should all equal to 0 once you distribute. Well, let's check. I'm going to underline all the c1s. It's supposed to say c. So how many c1s do I have? I have 4 minus 10 is negative 6 plus 6 is 0. And then underlined with green are C2s. You have 9 minus 15 is negative 6, and then another 6. Great, 0 equals 0. Yay. I just collected like terms. Basic algebra. So all I did is I took, once I know what the solution is, I differentiated that solution twice because I needed 2 derivatives, and I plugged everything where it belongs. In that respect, differential equations is an awesome course, because when you take that test and you have to solve a whole bunch of differential equations, you can check every single one of them. And it's, it's a lot of writing a little bit, right? It's okay. You can manage. And you will know exactly how well you did, because they all checked out. It's not like in Calc 2 where you do the problem and it's like, because you didn't take the derivative, check. Guys, test 2 is coming up, right? No? Solve integration. How do you check integration? Whatever you got as the answer, you find the derivative of it. If it matches where you started from, you're 100% good. If it doesn't, it's 100% wrong. And then it's just the mercy of the partial credit, right? All right. So now we understand how to check. We don't know how to solve any of the differential equations, but at least we know how to check for the if the solution is right. Now we're going to learn a technique called separation of variables. So this is technically one of those techniques that if this works, you do a little dance, okay? Happy dance, because this is the cheapest and the easiest of all techniques. It doesn't require you memorizing things. That's what I meant. There are much faster techniques, but you have to memorize things. Here, nothing. So let's work out. Remember all of those population models and the decay models and all of those wonderful word problems that you love so much? Mm-hmm. They all had the same formula, right? It was y equals a e to the kt. Now where it comes from? Well, differential equations and separation of variables is used to come up with that. Now let's immediately at the same time see why all of the physics, and all of the engineering, and all of the chemistry is driven by differential equations. So listen to the statement. The change in population is proportional to population. And kind of think about it and see that it actually makes sense. So, the change in population in time is proportional to the population. Okay. The change in population in time is dp dt. Word is means equal, proportional, constant of proportionality k, to the population. What we have is dp dt is equal to kp. That is the differential equation. So now what do we do with this? Well, separation of variables. So we're now going to separate the variables. We're going to put p's on one side and shift dt to the other side. Observe that the variables are separated. K is not a variable, right? K is a constant, so parameter. But both p and t are. So all p's on one side, all t's on the other. How do you undo derivatives? Integrate. So integrate both sides now. So what do you get? Thank you for the absolute. Exactly. Then we e both sides to free up that population. So now you have p of t is e to the kt plus c. Now hopefully you remember the algebra rule, which says that x to the m times x to the n is x to the m plus n, right? And we use it backwards. That allows us to split this into e to the kt times e to the c. C is the variable, C is a constant, A is a constant, so that can be combined into a major constant. I don't know, capital A, whatever. No, we have a name for it. I'll just use the regular name. P0. We started with words. The change in population is proportional to population. They make sense. Larger populations on the planet have greater change in population than those with smaller population. Which makes sense. So what we did is we took the words, translated those into mathematical equation, in this case differential equation, separated variables, integrated both sides, performed some of the algebra voodoo on it, and there we go. Population model. Now clearly this model is very bad, but it's okay. It's useful for the short periods of time. You don't want to use this and ask what's going to happen in next 100 years, because it's not going to be good. Entire physics, entire engineering, all the courses, all the branches, they all come from differential equations. So, as it's one of the most important subjects that you can learn in your undergraduate mathematics for survival at wherever you work. So let's practice separation of variables, and then we have another concept, and then we're done. Here, you're going to love this one. So remember, separation of variables is one variable on one side, the other variable on the other side, and then good luck from there. So this is problem 32 in textbook. No, next semester, spring.
Oh yeah. Oh yeah,
Now it's fall. It's fall.
yellow and orange. It's kind of cold.
Yeah, fall. No, not yet. Separate variables, integrate both sides. When you integrate both sides, you put plus c only on one side. There's no need to put c1, c2, and then combine them later. Just put plus c on one of the sides and you're done. Yes, some for us. Just to make you happy. I didn't say that. Put 5,000 meters. You just leave it We are going to separate variables. So we have dy over y is equal to x squared plus 1 dx. We are going to integrate both sides. Ln absolute y is equal to x cubed over 3 plus x plus c. And now we e both sides and we're done. Y as a function of x is equal to e 1/3 x cubed plus x And this plus c, you can break off as e to the c and then put in front as a constant. So there we go. Yes.
Can you even rewrite that to be like the original equation that yx equals e to the 1/3 x, that first one that you circled? Can you rewrite that as e x to the third over 3 ex ec?
Yeah, but there, don't chain those e's like that. There's no need. That's the answer. So one more problem, since there were some complaints about ln. Just to be creative, just go with the next one. 33. Can't be far from, right? What we did. This one is in terms of t. Awesome, right? So we have dy dt is equal to e to the y over 2. The y over 2 is an exponent, times sine t. T is the independent variable, y is dependent variable, depends on t. Find the function. Y. Y over 2 exponent, yeah. So separate the variables, and then integrate the hell out of it.
I'm thinking linear algebra here or something.
It might be going. The stats was the transfer.
Oh yeah, I wrote those when I was 25. Oh, you didn't know?
I think I got the right answer, but I'm not sure. I might have made an error.
Differentiate plus the Kinematics.
But like,
Just differentiate plus the Kinematics.
like, I don't know how to do it.
Okay, let's take a look at this problem together. Lots of fun, right? And I'm going to actually check the answer just to see how well it works. So here we go. Maybe color code. These are the two with y's. These are the two with t's. So obviously dt has to go to the right. So dy over e to the y over 2 is equal to sine t dt. And then we integrate both sides. Now, I will rewrite this one more time. E to the negative y over 2 dy is equal to the integral of sine t dt. So what is the integral of e to the negative 2 e to the negative y over 2? Very good. You can use the u sub if you don't know what's happening. Just this is the entire u, and then you will figure it out. Is equal to negative cosine t plus c. These minus signs will drop. No, no need. Only 1 plus c. And then we are going to double, do the half across. So we have e to the minus y over 2 is equal to 1/2 cosine t, and I'm still writing plus c. Observe that I completely ignored to change the sign of c as I divided through by minus 1. I ignored changing the sign on c. And now I'm dividing by 2 everywhere to get this e to the minus y, negative y over 2. I'm dividing by 2 everywhere to get that free, and I'm still writing plus c. This c is a constant which absorbs all of these operations. And we really don't have to worry about that constant at all. You just keep writing plus c every time. And then you will see later, a little bit later, how we find the value for that c. So we really don't have to worry about that plus c at all. We're going to ln both sides. So now ln both sides, and we have negative y over 2 is equal to ln of 1/2 cosine t plus c, and then times negative 2 everywhere. So this would be known as the general solution.
So the dy over dt, that first part, that is the differential equation.
This is differential equation.
And then the bottom is the
Solution for it, yes. So now I'm going to check this. And if it's wrong, go back and find what's wrong. So I need to figure out the derivative of this. So I need y prime, which is that dy dt, right? We are replacing dy dt by whatever we get here. It's negative 2 times ln, so copy the denominator as is and put its derivative in the numerator. Derivative of cosine is negative 1/2 sine t. These will cancel completely. All right, so let's check. We have sine t over 1/2 cosine t plus c should be equal to e to the, what was the original equation? No, positive y over 2. So y over 2, so there will be negative 2 ln of 1/2 cosine t plus c over 2, everything times, was sine t? Yeah. Yeah, it's a y. It's a y divided by 2, and y is the general solution in a red box. So now, this negative 2 in front of ln goes up as an exponent. Goes up as the exponent, so we have, oh sorry, these guys cancel, right? And then the negative 1 pops up. So we have e to the ln of 1/2 cosine t plus c to the negative 1 times sine t. These guys cancel, and you see that it's the same, right? All I did is I replaced in the original differential equation, I replaced dy dt by the derivative of the solution we got, and then I replaced y with the solution we got, and then follow the algebra from there. Everything cancels, and if you do everything correctly, you will get them to cancel to 0 equals 0, and that proves that that's the solution. Yes?
Why do you include the student
Why do I include C when I take ln? What do you mean?
like you ignored it for all the previous steps, but
Ah, okay. Yeah, there are certain cases when you can't ignore it. Okay, so here's what's happening here. When I got rid of the minus sign, I was dividing everywhere by -1. So divide by -1, divide by -1, divide by -1, but that gets absorbed, so, right, because we were dividing by a number. Next time, I did that one more time, I think. What I did? Divide by 2. Yeah, oh yeah, divide by 2. So divide by 2 over here. Divide by, that cancels. Divide by 2, and then I divided by 2. So divided by -1, it absorbed, no one cares. Divide by 2, absorbed, no one cares. But then, we took the ln. ln includes this one, and remember that logarithms are not linear functions. So it's not that you get ln of this plus ln of c. They break as ln of this times ln of c. Sorry, no, that's backwards. They don't break at all, actually. Sorry, it doesn't break at all. If the argument of the multiplication goes into an addition of logs. So this cannot be broken apart over here at all. So c stays inside. That's why. Let me write the formula since I said it wrong, so it's not confusing. The formula that works is that ln xy is ln x plus ln y. What you have is ln x plus y, which does not have formula for it. So that one doesn't break. If there was a formula for it and you can break it, then it will still absorb and it will be to c. Anything that you do directly to c as a constant to computation, no one cares. Take the square root of it, square it, whatever. You just keep writing plus b plus c plus c. It doesn't matter. But this was buried within the log. Okay. Yes? When I scroll down, I'm not sure where I need to scroll. Okay? Which one? This sign? This one? That's this. Oh no, that's the one from the original equation. Give me 1 second. So original equation was y prime is equal to e y over 2 sine t. So here's your y prime. Are you looking? Y prime equals e to the y over 2 times sine t from the original equation. Because we plugged everything in the original equation to check. Yes?
since you already derived the e is equal to y over 2 cosine e over 2 plus c, why can't you just put that in instead of e half cosine 2 plus c? And then
You want to check the answer, not intermediate steps. What happens if the mistake was in between somewhere, right? That would not see what I usually say to students, especially in algebra, right? You get the problem which has, and in algebra no one likes fractions. I don't know why, but so you have 1/2 x plus, I don't know, 3/4 y is equal to 8, right? And then they do a lot of work. Now, if you multiply this by 4, the equation, you get 2x plus 3y is equal to 32. But what happens if you forgot a part and you got 8 over here, right? The mistake is from this step to this step. And then you solve the solution and you get, I don't know, 3 negative 1, depending on what the other equation is. And now you're checking back. and you say, ah, it has fractions. Let me just plug it here. Of course it's going to work, right? Because the mistake happened before. So this solution, which is wrong, is going to work here perfectly, right? Because the mistake happened before this one, right? So that's why you want to, once you figure out what your solution is, you take the derivative of that and just make sure you are plugging everything back in the original printed equation. Printed equation on a test, but obviously as an engineer, you will be plugging it back into whatever the model is. Any other questions? I see some expressions of pain.
So you're not like differentiating anything.
We differentiated in the check. In the red box is the y equals, which is a solution. And problem is done. You have the solution, you can walk away. But then you say, is it right? So then you differentiate, because as you can see, your differential equation has a derivative that you need to plug for, and original function that you have to plug for. So we differentiated our solution, got this, and then I plugged into original problem. Here's your derivative, that's that part, equals e to the original box solution divided by 2 times sine. So this line over here is your original equation with y and y prime plugged in. Those two. And then you just put the algebra, and there you go. You're talking between the, for the first derivative. I took Calc 1. It's ln. So the function, and then its derivative on top. It's f prime over f. Yes.
So like first, like what's the significance of C1?
Those are constants, because what you're getting is exactly the same like in your calculus 1 you have plus c, which adjusts the height of the function. And if you get a point, then you can calculate what plus c is, and you will have only one function knowing exactly where it is. It's so particular. Now you're going to have ABC, only C, in this one. For the case that I gave you earlier, there was C1, C2, there will be a and so on, so fine. So significance is that it shifts the function to actually equal the points that we call initial demand. So we figure out whatever it is. Now we have to discuss what we call the first order linear differential equation. You can either use separation of variables to solve them, or you can memorize how it looks like, the solution, and you just plug in values and you're done in one step. Now obviously if there's no work and you get it wrong, then there's no partial credit either. I'm sorry? Oh, the test date, yes. All right, let's take a look at this one. Guys, pay attention, I'm talking about the first order.
Star Wars.
So first order linear differential equation has the form of y prime of t is equal to ky plus b. Does this look like mx plus b?
Yeah.
Sure it does, right? So linear means no exponents on y. First order means it's just the first derivative present. So this is how the equation looks like. Now, solution is y of t is equal to ce to the kt minus b over k. That will be the solution. So you can memorize how solution looks like. So if the question says, right, you can immediately do it. Let's say, that's not a y. Y of t is equal to 3y minus 8. You go, k is 3, b is negative 8. Therefore, solution y of t is equal to ce to the 3t minus plus 8/3. And you're done. Right? Or, if you don't want to take the memory up, right, for that, you can solve it through separation of variables. So that's the solution. Or, you would say y prime, is dy over dx, which is 3y minus 8. Separate variables, which is dy over 3y minus 8 as a group, is equal to dx alone. Integration on both sides. Over here, we have a u sub to get the ln, right? But there is the 3 in front. Do we see it? Yeah. So u equals 3y minus 8, du equals 3 dy, and then you need a 3 in front and a 1/3, right? So need a 3 over here and 1/3 in front for your u sub. So we have, to cut it short, you will have ln du over u, so it's ln of u, and u is 3y minus 8. Equals to x plus c. Both sides times 3. Remember that c would absorb it, so we don't need to put 3c. We e both sides, and we have 3y minus 8 is equal to e to the 3x plus c. Sorry, 3x plus c. Now that is going to separate, and you're going to have the constant, let's say a. Because right, we define that. And all you need to do now is to move 8 to the other side and then divide by 3. So it will be 3y is equal to a e to the 3x plus 8. And then you divide by 3, but remember constant absorbs it. So I get y as a function of x is equal to a e 3x plus 8 over 3, which is exactly what we had here because we memorized it. So whether you want to do separation of variables, or if you want to do memorize the solution and just plug numbers in, it's up to you. So I would still like to talk about one more cool concept, and that is your kinematics of motion in physics. So we can see how this works actually, and why did I make the claim that all of your physics is differential equations and everything else. So let's observe the experiment. Look at the experiment. Whoops. Right? So there's the gravity, because this planet is much bigger than the eraser. So when you take a look at the ratio of mass of the planet towards this eraser, it's very difficult to see how much this eraser pulled the planet up. But it did, actually. So thinking about this, when this goes down, the planet actually goes up a little bit as well. Now, it's such a small amount because the ratio of the mass of the planet and this eraser is huge. So that's why we do not feel planet going up. But the gravitational pull of Earth is enough to keep the moon in orbit, right? So now, we have the experiment number 2. So this is the experiment number 2. It's called parabolic motion. Anything that you throw, it's going to go into parabolic motion. Now, what were the aspects of that flight? First of all, you see that the object eventually went down because the gravity pulled down. But you also see that the object ended up all the way there because of me throwing it, which added the initial velocity. I can throw it like this, and it doesn't go that far. Right? Now also, I can throw it with the same strength from a different height. And if I throw with the same hand from a different height, it's going to go further. Or, if I go from the lower height with the same strength, it's not going to go as far. So, what are the aspects of the parabolic motion? Definitely gravity, right? That's going to pull down. We have the, it doesn't pull down, but, and we have the initial velocity, and we have the height from which I throw. Great, let's start with gravity. Gravity is acceleration, and acceleration is change of position, right? Change of velocity in time. So that's the acceleration. You have your gas pedal and your brake pedal in your car. When you push gas, you are changing the velocity to positive side. When you push brakes, you are changing the velocity in a negative, right? The speedometer shows exactly what's happening there. So you start with a claim that acceleration, which is the gravity, right? And then you say that it's change in velocity in time. You can say negative g, because it's, right, pulling down on the y-axis. And now when you separate variables, look what you got. You got yourself, right, separable differential equation. You solve that. The integral of this is the velocity, and on the other side you have negative gt plus some constant c, and you will call that constant c initial velocity, velocity 0. So look what you have. Do you remember your velocity final is equal to velocity initial plus at? That's that equation, except now we have acceleration to be free fall minus g. Remember that? Awesome. So now you're going to say, but wait, what is the velocity? Velocity is change in position, right? If you have velocity, you can change the position in time. So if you're going 50 miles per hour, you can go from point A to point B, right? In 1 hour, 50 miles. So velocity now is going to be change in position over, let's use y. It doesn't really matter. In time. So now what you get is dy dt is equal to v0 minus gt. Well, separate the variables again, which means this dt goes to the other side. And we have dy is equal to v0 minus gt times dt. Separable differential equation, right? Integrate again. Y is equal to, and what do we get? V0t minus gt squared over 2 plus some constant c, and we call that constant c initial height. Rearrange the terms, and we get remember that equation? Of course, parabolic motion. So this is how all of the physics is developed using similar ideas. You say some words and you transform those words into differential equation. Now obviously not every equation is separable equation, but many were. And you can come up with all entire physics. Now what you have here, this is linear motion, right? Straight line. You can replace these letters with omegas, alphas, and thetas, and you will get all of your rotations. There we go. So that's it. Aim 1. Aim 2. That's the exercise for today. Awesome. Yes?
For linear, the first order linear differential equation, is C always the initial of whatever?
Yes. Always. And that's that for differential equations for now. We'll talk a little bit more next class when you guys figure out the homework and see what you don't know and ask. Now let's